Good day, learners! Before we start, here are some tips to help your posture if you sit a lot in front of a computer. So first, support your back. Number 2, adjust your chair. Number 3, rest your feet on the floor. Number 4, place your screen at eye level. Number 5, have the keyboard straight in front of you. Number 6, keep your mouse closed. And number 7, avoid screen reflection. And last but not the least, number 8, avoid wearing bifocals. There you go! You are now ready to begin. What comes to your mind when you hear the word volcano? Very good! Some of you answered lava, magma, ash, and slope. So, there are different types of volcanoes. So first, we have the active volcano. So active volcanoes are volcanoes that have had recent eruptions or are expected to have eruptions in the near future. Second, we have the dormant volcanoes. These are volcanoes no longer produce eruptions but might again sometime in the future. And last but not the least, we have the extinct volcano. So these volcanoes will likely never erupt again. Do you know the active volcano in the Philippines? Here are some of the active and dormant volcano in the Philippines. First, we have Mount Banahaw. Next is Mount Bulusan, Camiguin de Babuyanes, Mount Hibok-Hibok. Next is Mount Iraya, Mount Iriga, Mount Canlaon, Makaturing, Matutom, Mount Mayon, Mount Pinatubo, and lastly, Taal Volcano. Can you locate them in the map? Very good! So Mount Banahaw is in Laguna and Quezon, Mount Bulusan in Sorsogon, Camiguin de Babuyanes in Cagayan, Mount Hibok-Hibok in Camiguin, Mount Iraya in Batanes, Mount Iriga in Camarines Sur, Mount Canlaon in Negros Occidental Oriental, Makaturing in Lanao del Sur, Matutom in South Cotabato, Mount Mayon in Albay, Mount Pinatubo in Zambales, Tarlac, and Pampanga, and last, Taal is in Batangas. What can you say about these pictures? Very good! Collapsed building, broken road, these pictures portrays an earthquake. Earthquake epicenter is the projection to the surface perpendicular to the hypocenter that reflects the intensity of an earthquake and also a product of the liberation of tensions in the failure or weakness area in the Earth's crust. The focus is the place inside the Earth's crust where an earthquake originates.
directly above the focus is what we call the epicenter. When energy is released at the focus, seismic waves travel outward from that point in all directions.
Are you familiar with this picture? That's right. This is a triangulation. So it is a way of determining something's location using the location of other things. It is commonly used by the geologists to find the location of earthquakes. But before we move on to our activity, let's have some recap on your mathematical ability. So here is the formula to be used in our activity today. D is equal to TD over 8 seconds multiplied by 100 km, wherein our D is the distance and TD is our time difference.
For example, we have sample recording station which has a time difference of 48 seconds. So using the formula for distance, let us now compute the distance from the recording station. So 48 seconds will be our time difference. Let us now substitute the 48 seconds in our formula. Distance is equal to 48 seconds divided by 8 seconds multiplied by 100 km. So step by step, 48 seconds divided by 8 is equal to 6 multiplied by 100 km. Therefore, we have 600 km. Since 600 km is too long to plot in our bond paper, we will use scale. So, for every 1 centimeter is equivalent to 100 kilometer. So, let's try our distance. 600 kilometer multiplied by 1 centimeter divided by 100 kilometer. Therefore, we have 6 centimeter. Did you follow? That's great! Let us now begin with our activity. These are the materials needed in this activity. First, we need hypothetical records of earthquake waves. Also, Philippine map. And of course, drawing compass and ruler. Lastly, our marking pens with 3 different colors. All we have to do is first compute the distance of the epicenter from each of the stations using our formula. Distance is equal to time difference divided by 8 seconds multiplied by 100 kilometers. Second, choose one of the recording stations and measure the computed distance on the scale. So our scale of the map is 1 centimeter is equivalent to 100 kilometer. So after you compute the scale, set your compass for that computed distance. Center your compass on the station you have chosen. Then draw a circle. After that, repeat steps 1 and 2 for the rest of the stations. You should get 3 circles that intersect or nearly intersect at a point. So this intersection is what we call the epicenter. Let us now begin with our activity. for today. See you on our next lesson. Goodbye!